Think forward. Think Research Channel.
Thank you for the opportunity to give you the geological perspective. Some of the things that I say today, first of all, I teach here, I'm a professor, I teach geology, hydrology, watershed science, and I infuse in my classes as much as I can information about the global environment and the geological history that we can learn from and steps we can take to improve the environment. Some of the things that I'll say today may seem heretical in light of the other talks that you'll hear. I would say that whether or not, global warming is definitely occurring. CO2 is definitely rising because of human influence. Whether or not that's linked to an increased temperature, I think is still debatable. Nevertheless, my take-home message is that greenhouse gas emissions should be reduced for a variety of reasons. Whether or not it's actually a solution to global warming, there's lots of good reasons for sustainable living to reduce greenhouse gas emissions. This is North America 100 million years ago. You can see Florida is underwater, sea level comes up past Tennessee and nibbles at Kentucky. There's a seaway that goes right through the middle of the continent, making a kind of a big long island on the west coast. We can learn about natural variability in climate and conditions by looking at the past. This is a geologic map that shows the evidence for that seaway. Here's Florida. The yellow and tan rocks are the 100-million-year-old marine rocks that lie on top of the continent. There's no other way to get those there but to have had a seaway. When you look at sea level for the past 500 million years, with 0 being our sea level today, it's fluctuated 200 meters above what it is today. That's how it got to Tennessee. That's about 200 meters in elevation. It's also, in the more recent past, dropped 130 meters below today, all before human evolution. The last 2 million years, when humans and things that pretty much looked like humans and had pretty much the same values and goals, 2 million years, has seen maybe between 20 and 30 ice ages. So our ancestors have seen lots of change. Ice ages come, ice ages go. If you look at the climate record based upon the ratio of oxygen-18 to oxygen-16 as trapped in fossils, you can see that through that last 500 million years, there's been lots of ups and downs. We live in a pretty cold part of that history right now. Let's look at the most recent 1 million years and look at the variation there. High on the graph is warm, low on the graph is cold. If you sort of smooth out that curve, you can see, well, here's starting 1 million years ago. Here's one ice age, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we're coming out of the most recent ice age right now. If you look at just the last 140,000 years, we're getting closer to today as we focus in. Here's an ice age, warming to present temperatures or above, and each of these ice ages came to present temperatures or above in the past. And then our decay into our most recent ice age, which ended 18,000 years ago, and then a steep rise in temperature long before the Industrial Revolution. The point is that when we look at global change, there's a lot of things that go on in the absence of human interaction with the environment. And it's that lesson that we have to keep in mind. We're trying to tease out a little bit of change here at the end within the context of so much change that's gone on before. I want to show you a little animation. See, sea level keeps track of tracks with climate change, because when the temperature drops, ice forms and it pulls water out of the basins. And then when ice melts, basins fill up with water, and there's thermal expansion that increases the water volume. So this is a little animation put together by Alex Hoffman and myself. This is Monterey Bay. Here's Moss Landing, Monterey Peninsula, Carmel Valley, Carmel Canyon. We're sitting right about here in CSUMB. Here's Lover's Point, Monterey Canyon, Monterey Continental Shelf. These numbers are thousands of years before present. So we're watching sea level rise, 16,000, 15,000, 14. This is our most recent ice age melting. What you might not realize is if I freeze time right there, Native Americans were here at that time. They had a lot more land. That's not so long ago, 10,000 years ago. People were here watching this happen. We advanced 9, 8,000, 7,000, 6, 5, 4, 3, 2, 1. Then we flood Elkhorn Slough and a little bit of water in the Salinas Valley. The artificial part of this is the animation stops now, when of course it doesn't stop in reality. The lesson is that global change is part of who we are. It's been changing for hundreds of millions of years from day one, and it's continuing to change today. We look outside and we see the environment, and we think that's the thing we want to conserve, we want to preserve that, that's our home. Our home is change, and we have to address that. We have to embrace it and work with it for sustainability. Thank you, Bill. That's not to say we sit back and relax and do nothing. We'll talk about that later. What are our options? What behavior should we have? These are things that we're going to discuss today as the day progresses. Whether or not we're involved in the change of climate or not, whether or not all the answers are in, there are important decisions that we can make right now that make a big difference. So about every 100,000 years there's an ice age, and then there's not. And that's not because of anything we've done. It has to do with very tiny adjustments in how much sunlight hits the Earth. There's the precession of the, small changes in the Earth's orbit basically influence how much solar energy hits the Earth. And if you add up all of the known cycles of Earth wobble and all that, you get a 100,000 year cycle that matches ice ages really well. So we can't change that. We cannot influence that 100,000 year cycle. That's part of the geometry of our planet. So what we're talking about is doing other things. Global warming solutions. The title suggests that global warming is happening. Is it abnormal or bad? If we're trying to solve it, it implies that it's bad or abnormal. I think from the previous slides you can tell it's not abnormal. We're on a planet that swings heavily in terms of climate, and it swings sometimes fast. Is it bad? There's going to be economic consequences. There's going to be extinctions, perhaps, of polar bears and other things that we hold dear. That's a value judgment, and we have to decide if we want to act to prevent the bad things. The abnormality, I would argue, isn't there. I think that this is the climate changes that we've seen so far are certainly within the realm of what's happened in the past. Has human behavior caused it? There's an intergovernmental agency that says that, yes, we have caused it. I still say the jury is out a little bit there. It might be heretical to say it at this point, but I'd like to see a little more evidence. It doesn't matter to me. My actions will be the same. I still think greenhouse gas emissions should be reduced. If we've caused it, perhaps we can solve it. We certainly can't influence the 100,000 year cycle, but maybe if our greenhouse gas emissions have caused us, an increase in temperature, perhaps our reduction of those gases can reduce further acceleration. Most important, what does a solution look like? How are we going to know if we've been successful? We're an outcomes-based institution. Outcomes are accessible. They're well articulated and they're accessible. How will we know? Unless we know what background really is. What's natural? Change is natural. There's no question of that in mind. We're not going to hold this climate the way it is. That's not going to happen. So how much change are we shooting for? It's an interesting question. I'd like it to be accessible so we know if we've made a difference. So it's not abnormal. It will have some negative consequences, big negative consequences, especially along coastal communities. Have we caused it? I don't know. Can we solve it? Don't know. We need to clarify our intended outcomes. Just want to leave you with certainly some data here. Is global warming happening? Definitely. We've got surface thermometers. They're not the greatest. We're getting better ones, but it shows a rise. Satellites also show a rise. Ice volume is one of the best ways to look at this. Here's surface thermometers. Since the Industrial Revolution, temperature has been rising. Turns out a lot of the sensors that are used for this diagram are not in the best locations. Urbanization has come up around these sensors, and it may be influencing them, actually. When you pave the area next to a temperature sensor, it reads a higher temperature. So there's a study that's shown that actually 85% of these sensors are in urban settings where they're getting some kind of false reading. Satellite work doesn't look exactly at temperature, but it looks at radiance. And you can use a mathematical formula to turn that into temperature, and it validates the surface thermometers to some degree. So it looks like satellites, surface thermometers all agree that there's about a 0.2 degree Celsius rise per decade. More compelling to me is the huge global changes that are going on that are definitely the result of warming. This is the same spot in 2004. Here's an arrow pointing at this little hill. That hill is that hill. And the ice volume reduction globally is phenomenal. One of our local researchers, Wisław Maslowski and Jacqueline Kinney at Naval Postgraduate School, has been looking at the aerial extent of Arctic ice over the past few decades from satellite work, and they show that there's been a 30% decrease from 1979 to 2005. That's a little startling. I'm going to show you pictures from 1996 to 2005. That's the North Pole. Here's the sea ice extent at the summer minimum in 96. And then it's just fading. It's not really an animation. It's just fading to the 2005. But you can see in that amount of time, the summer ice is disappearing. And in the paper this week, he was quoted as saying, if you take that trend to its logical end, we're not going to have an ice cap during the summer as early as 2013. Nobody thought it was going to happen that soon. So people talk about accelerations. This is one of them. This is really happening. There's a feedback between when ice disappears and global warming because the ice is reflective. And so when there's no ice, things warm up even faster. Is it abnormal or bad? We've touched on that. I just want to show those slides again. The Earth has been changing its climate continuously and will continue to do so no matter what we do. Has human behavior caused it? There's a panel that says it has. Temperatures rise since the mid-20th century is very likely due to the observed increase in anthropogenic greenhouse gas concentrations. Very likely due is not a very good scientific result. We don't even publish when we have very likely due. We shoot for 95% confidence. We don't have that yet. So this is an opinion, an expert opinion at this point. May be valid, might not be. Three things can cause change. Variation in the sun, that has not been well correlated to temperature change. Variations in Earth-Sun geometry, that's what runs the 100,000-year cycle. And variation in greenhouse gases, which is where we come in, because certainly greenhouse gases do trap heat, and we are producing greenhouse gases. So if you look at CO2 over the past few thousands of years, the CO2 levels do track the ice ages very well. There's a correlation, a strong correlation, undeniable. But the first thing you learn in statistics is that correlation does not imply causality. The last little piece of our history shows a big spike in CO2. That's real, and that's us. Whether or not that's going to cause temperatures to rise is the question. If it is, it would be neat to know that all the other ice ages that have happened show CO2 coming out and then temperature rising. When you look at the most recent the end of our most recent ice age, as Lowell Stott just did, this is just coming out, he finds a 1,300-year lag between temperature rise initiation and CO2 rise initiation. So the causality here is a little funny. It could be that the 100,000-year cycles start because of the orbital stuff and then pump out a little CO2 because as oceans rise, temperature rises, CO2 comes out. And then the CO2 adds to the effect. That could easily happen. There could be interactions. But the whole story is not out here. That's all I'm saying. We don't know yet. So global warming is happening. No question, Earth has always been changing. Given the uncertainties, how should we behave? Here's a little decision matrix. Truth is across the top. Either human climate influence is real or human climate influence is not real. Those are our two choices. One of them is true. And our behavior is either do nothing or reduce greenhouse gas emissions. And here are the results of that. If we do nothing and our influence is real, we have some serious problems. If we do nothing and we're actually delusional about our influence on the climate, we get a degraded environment because we're still burning greenhouse gases. If we reduce greenhouse gas emissions and human climate influence is real, we might have an effect. We might be able to reduce the rate at which climate changes. We're not going to stop it. And if we're delusional about human climate influence and we reduce greenhouse gases, there's a whole bunch of positive things that happen anyway. So given the uncertainties, I would definitely advocate reducing greenhouse gas emissions. It may be that we'll have an influence. We'll definitely enjoy some benefits. Thank you very much.
Good morning. Good morning. Everybody take a big stretch. Come on. No one's supposed to sit still for 50 minutes without moving. It can't be right. I thank you for the invitation today. I'm honored to have been invited. I'm not here today representing any tribal nation, not even my own. I'm Osage and Kaw. I'm from Oklahoma. But I am here to pass on to you the messages that have come from Native America. We have been studying this issue for quite a while. Many federal and state agencies have even gotten interested in Native voices on this issue. And as long as 10 years ago, the National Space Administration funded a series of conferences that brought our elders and representatives from over 180 tribes together in Albuquerque. And what I'm going to do today is, certainly I'm going to speak for myself. I have an opinion on the matter, and so I'll share that with you. But I also want to share with you the opinion and the statements from at least 180 Native elders who attended this special conference on homelands of climate change. It was funded by the United States Global Change Research Program, and the message that was delivered was developed, well, let's admit, it was developed scientifically. They used focus groups with Native elders from around the world, and the final report is called the Albuquerque Declaration. I'll leave a few copies of the Declaration in back later on, but of course you can always Google it and download it in its full splendor, 76 pages of data. Now, I'm not going to spend this next 30 or 40 minutes sharing with you everything in the Declaration, but I do want to share with you a few things. And since my electronics aren't going to work, I'm going to use a statement that was once attributed to Will Rogers, who once said that most people can remember 3 things without PowerPoint. Yeah. I'm not from California, but I should, to give a nod to my California brothers, there are 250,000 Indians in California. That is the second largest population of American Indians in the country, second only to Oklahoma, my native state. There are 100 federally recognized reservations and 40 groups currently seeking recognition by the federal government. Most of the native people of California live in urban areas, although the anthropologists have divided the state up into 3 sections. But the 3 points I'd like to make for you today include some of the statements that come from, okay, so the clip's not going to work. Well, let's begin. The clip I was going to show was a little video shot of a gentleman named Iron Eyes Cody. Many of you remember the ad. It was a public service ad. Iron Eyes was in his canoe and floating down the river, and he observed trash floating down the river, and the close-up at the very end is the Indian crying. Now, in Indian America, we all know that that was a glycerin tear, but the image has stuck for nearly 40 to 50 years in the Americans' mind about Indians and pollution Indians and their opinion about the land. You see, we live in interesting times today. Anthropology and archaeology tells us that every stage of human social evolution exists today at the same time. You can find hunting and gatherers living today, horticultural cultures, agriculture. The industrial age is happening in countries like China right now, and the post-industrial information age has exploded on us, particularly here in the Silicon Valley area. We are all living at these different stages of development all at the same time. I once had a friend trying to explain to me what postmodern meant, and in my mind that's what it means. It means that someone not very far away is living close to the land, living off the land, while those of us just blocks away are living on the internet. Native people evolved with the rest of our species from a singular population nearly 240,000 years ago. And during that 240,000-year history, for the most part, it was not written down. What we know is oral history. Again, what's written down goes about 10,000 years back. But Native people here in the United States have continued to tell their stories even without that written language, and that's what the scientists at NASA were interested in. What were those stories from Native America? How has the climate changed? What have the elders noticed? The fact of the matter is, because Native people live close to the land and with the land, it is a personal experience that they have felt first. Let me say it again. We have felt it first. So I'd like to summarize the 75-page report from 180 different tribes for you into 3 statements and a few personal observations around each one. Now, the first observation I'd like to make to you from the Albuquerque Declaration is as follows. American Indian and Alaskan Native leadership from natives, tribes, bands, villages, pueblos, rancheros, and communities across America know what is happening, they know who and what is responsible, and we're concerned about the impacts of global warming. Now, again, in deference to our last speaker, it's probably true. The planet has changed naturally. American Indians understand that. We've watched the planet change. But what we're experiencing is not natural change. Large population shifts, migration, pollution, these things are not natural. They were not created by the natural world. They were created by human beings and their interference with those natural processes. Thus, where our observations appear to support most of modern science findings, we call upon the leaders of the world at all levels of government to accept responsibility for the welfare of future generations. 180 tribes agreed on that message. Now, my own observations come from growing up on an Indian reservation. In fact, I grew up on 5 Indian reservations. I'm one of those transitional generations. My family likes to talk about dancing in 2 worlds. One world is that world of sustenance living, where families and entire communities hunt and grow and share together. I grew up on the Shoshone-Bannock Reservation, and every spring we'd go up and do salmon spearing. I was a kid, so that meant that I threw rocks and jumped in the deep pools and chased the salmon out, and the adults did the spearing. But the fact is we put the best spears at the best place, and the food was taken to the camp where it was smoked, and then it was equally distributed throughout the community that I grew up with. Deer hunting was the same. We'd give all of our deer tags if we were off reservation. If you were on reservation, you shoot what you want, to the best shooter. And the rest of us would storm down the canyons and chase the deer into the best shooter's range, and then the deer would be taken care of and shared amongst the families. My voice is that the salmon are gone. I have seen this in my lifetime. The communities that speared salmon, they too are gone. The practice of sharing resources It's still there, but the resources that we share are not the resources that come from the land any longer. I grew up sledding on plastic coats on small glaciers that you could walk up to in 20 or 30 minutes. Those glaciers are no longer there. The canyons that we chased the deer down now have condominiums on them, and there's population sprawl. The first reservation I grew up on, the Shoshone-Bannock Reservation, was an interesting place. My friends, I lived in relatively middle-class housing, government barracks. But my friends lived in hogans, in stick huts with dirt floors, and in boxcars. Shortly after we arrived on the Shoshone Reservation, the HUD folks moved in, Housing and Urban Development, and they built some spec homes. There was a little old man named Tagwatts that I learned a lot from. Tagwatts had a wagon and a dog, and his way of making a living was to collect pop bottles by the side of the road that people would throw out. We made a lot of fun of him about it until I figured out how much money he was making because I wanted to buy comic books, and Tagwatts and I got in a little pop bottle war. Now this is kind of important to me because my dad bought me out. He told me that if I'd quit picking that stuff up because it embarrassed our family, he'd give me an allowance, which I did. I learned to make money the same way the tribal council did, and that was by letting people trash the reservation with strip mining for phosphate, a company called Simplot Fertilizer, who had large companies that were downwind from our home that polluted the air. The tribe made good money from it, just like I was making good money by letting the trash lay on the road. Well, it's those kind of observations that make me think that, well, I know I'm not an elder, but when I start having those types of observations, maybe I am an elder, because I've seen it change myself. Everyone's migrating to town. The men work in the vegetable canning factories, the salmon no longer spawn, the snow no longer comes, the lodge poles no longer grow. It's changed in my lifetime. The second observation that I'd like to make from the Albuquerque Declaration tells us that global warming is a matter of environmental justice. Exploitation of traditional native homelands have left many, if not most, of our native communities stripped of their traditional ways of making a living. To quote Robert Bullock, a rather famous sociologist known for coining the phrase dumped on Dixie, it's very true that low-income communities have been used by factories and other sources of development because of their inability to organize and stop the pollution in their communities. This happened with American Indians. And part of the problem that we have as Native people is a stereotypical view that you have of us as being non-polluters. You see, our oral histories tell us that this has happened before. The Anasazi of New Mexico, they disappeared. It's clear it was population explosion, and we exceeded the size of our water resources. Today, the reports coming from the Navajo and the Apache of the northwestern regions are all very similar. The water is disappearing, population growth has reached its limit, and the elders are saying, get ready, it's happening again. Deforestation, contamination of land and water by pesticides and industrial waste, and then my favorite, toxic and radioactive poisoning done to Native people without our say. But what's even worse are tribal councils around the country who are now accepting industrial waste as overflow from folks like New York City, or indeed doing long-term storage of radioactive waste because we have the land that's quote-unquote barren and geologically stable, and our councils are accepting that waste as a way of making an income. Indians have been assaulted like this before, and we understand that this is a human cause, not a natural cause. I mean, the human cause was far more available and far easier to see during the Indian Wars, but we believe that this is a human cause too, and that the source is the same. Traditional values of harmony with the environmental resources have been replaced by a Western model of exploitation and uncontrolled consumerism. I don't think I'm an elder, but when I start making these types of personal observations, I'm beginning to wonder, maybe I am. So we have these changing values. We made fun of tagwats. My dad made fun of tagwats. Tagwats got one of those spec homes. First, one of the elders on the reservation to get a real home. You know, it was a little house, gas stove, flush toilet. He'd never seen a flush toilet before, never seen a gas stove. How many of you know how to change a light bulb? Yeah, everybody, right? Well, imagine seeing a light bulb go out and then wondering what to do about it. And the more curious thing about good old Tagwatts was when he got that spec home, it was also tied into the electric grid and to the gas grid, and within a month he got his first set of bills. He'd never received bills for electricity or gas before, and when the electricity went off, he opened up the house, took out the windows. When the stove quit working, punched a hole through the roof, brought the wood stove back in. When the electric lights burned out and quit working, back in came the old lighting systems. He surrounded his home quickly with a boarded fence, dug an O in the backyard, that's an Indian slang term for an outhouse, and he was off the grid once again. It's hilarious. They hired consultants to come in to teach native people how to become dependent on centralized power sources so that they could get back onto the grid and contribute to this growing thing called consumerism. Today, of course, my mom is an Oklahoma environmentalist, and she has been rewarded numerous times for her pop bottle and can drives. It kills me to think that my family has come full circle to understand that old Tagwatts really did have it right. Native Americans, and this is my third observation from the Albuquerque Declaration, Native Americans can play a significant role in shaping how America addresses and generates our active responses to combat global warming. Once again, we have thousands of years of traditional knowledge, and we have connections to the environment, and we have dealt with this issue before. What we have learned and our testimony clearly support the observations of modern science. What's not yet been tapped is how we adjusted and how we adapted to this change. I think there's a little bit more work to be done as we look into how American Indians, native people around the planet, have managed to survive so close to the environment when it continues to change even within this generation. Again, I don't like thinking that I'm an elder, but I've seen it, and we've now published, and some of our scientists are now reading it. Some of you can too. Google it. It's on the web. A couple of last points. The elders around the country organized themselves into traditional categories that I'd like to share with you. In the eastern woodlands of the United States, the message from the native people there: population growth and urbanization have destroyed us. The folks in the eastern woodlands were the first to feel the invasion from Europe, and that population invasion traumatized them. It shattered them, and it split them apart. That population growth and pressure pushed them out of their areas. Today, what they're seeing is urbanization. And again, I'd like to share with all of you that the popular conception of American Indians living on reservations is just not the case. Over 50 to 60% of all American Indians live in urban areas. 20% live in rural areas, and a minority, 20%, live on Indian reservations. It's in the rural areas and on the reservations where we see Native people struggling to maintain their close relationship to the land. And most of what we're seeing in that struggle is due to population growth and industrialization. It's been uncontrolled. In the Great Lakes, the world's largest body of fresh water, it's been polluted. There are invasive species. It's a major migratory pathway, and that pathway has been disrupted, and it has changed the way Native people living close to the land on how they are practicing their agriculture as well as their sustenance hunting. The reports are very clear that urban sprawl and industrial pollution are changing the way that we have to live. In the Great Plains, that's where my people are from. Many of you are familiar with the Great Plains, and you know that we have incredible weather extremes. I've grown up in Oklahoma and the area, and this particular winter was exceptionally difficult on us. All of the pecan trees on my land in Oklahoma were shattered this year by one of the most incredible ice storms that we have ever seen in nearly 100 years. It flattened the place. My family, which prides itself on being able to stand on its own and live off the grid, was curiously caught flat-footed this year, had no electricity, and ended up in a shelter for over a week and a half. Fascinating. My tribe stepped forward and provided portable generators for dozens of communities throughout northern Oklahoma during this period of weather extreme. Furthermore, the water's disappearing. The water's disappearing. More importantly, there's a demographic shift. Now again, demographic shifts are something that Native people are pretty familiar with. In fact, most of us are pretty, we find it quite humorous, all of this business about migration policy and immigration policy, because we didn't have one, and look at the results. In Oklahoma today, my family can't quite understand why you can get a $1,000 ticket and spend 3 months in jail for helping an illegal immigrant by giving them a handout, a ride, or putting them in their home. Oklahoma is in the middle of an incredible demographic shift, one similar to what California went through nearly 10 or 20 years ago. I may have to go home to help them with this one. Mom can't understand why people are speaking Spanish at her favorite restaurant. The agro-ecosystem in Oklahoma is beginning to collapse again. This area here in California is closely attached to the area that I grew up in. The Dust Bowl created what one country western song that I hear on KPIG radio sings. It says, "The only people in the Salinas Valley are Okies and Mexicans." Curious how that demographic shift occurred. Consider what might happen to the valley that we're in here if what's going on in Oklahoma happens here as well. The Dust Bowl is on its way back. We expect larger tornadoes and greater temperature shifts. We're already seeing extremes of 30+ degrees in a 24-hour period. And then the Southwest, just to close, it appears to be water again. The Native people in the Southwest, they're smiling. They've seen this before. It destroyed their civilization. It looks like it's going to happen again. We expect temperature changes of 5 to 9 degrees, colder winters, hotter summers, not enough water to go around, and a collapse of the tourism industry, a collapse of the agriculture industry, and forced migration. But we've gone through that before. And that's the message, I believe, needs to be passed on, so that as we do our next round of studies, it doesn't really matter who's caused this problem. We're going to have to solve it. There are some solutions from Native America. Thank you.
In order to really think about our greenhouse gas impact as a result of mobile transportation, there's one critical piece of technology that I want to mention to you that is perhaps responsible for a lot of the added carbon in the atmosphere today. That is the internal combustion engine. That is the engine that is within your car. And it's called an internal combustion engine because there's an explosion in a cylinder which forces a piston to go up and come back down. which that energy allows us to propel vehicles, move cars, eventually to fly planes, all that kind of stuff the internal combustion engine is a critical piece of. So I want to give you a little bit of history on the internal combustion engine, just a slide or two. And I'm going to pose a question. What was the first internal combustion engine? What do you think it was? Well, it was the Cannon. Cannon, a couple thousand, well, the history of the cannon, my understanding is the Chinese first invented the cannon a couple thousand years ago when they invented gunpowder, which was the first fuel. The fuel for the cannon fires the cannon's piston, which is the cannonball, and you get to fire it once. But the cannon has a lot of similarities to the internal combustion engine. The internal combustion engine has a cylinder, a metal cylinder usually, and it has a piston, and so does the cannon. And it has a fuel source, which in this case is gunpowder. And indeed, when people decided they want to do things besides throw cannonballs at each other, they thought, oh, maybe we can use this for something else. The first fuel they tried to use for engines was gunpowder, believe it or not. It didn't take long to realize that didn't work all too well. It caused damage to whatever sort of engine you're trying to build. It's also very difficult to control that. So we tried a whole lot of other fuels. Now, keep in mind, this is in the 19th century, the 1800s. All of these fuels were used. Some very interesting ones that you may not have thought of. Turpentine was a fuel that was used in some of the earlier engines. Ethyl alcohol, which is ethanol, which is what we're trying to use now in some cars, was used back then. And so was hydrogen. The model for the first hydrogen internal combustion engine was built in 1820. So it is not a new fuel by any stretch of the imagination. So why are fossil fuels a problem? Many of us may know this, but we may not all know this, and I kind of want to put us all more or less on the same page. When you burn fossil fuels, you are taking carbon that was sitting in the earth for several hundred million years, which used to be plant life, hundreds of millions of years ago, and absorbed atmospheric carbon dioxide back then to create the world we have now. That died, went to the bottom of the ocean, was buried, became oil. In simple terms, we mine that oil, we pull it out, we burn it, we return that carbon to the atmosphere. So we are increasing our carbon footprint significantly by burning fossil fuels. Then what are biofuels and why can they help us? Well, I just told you about fossil fuels. Think about the biofuels, the plants that are absorbing the sunlight and the atmospheric carbon dioxide today. The sun shines, the plants grow, and they're absorbing carbon dioxide in the process. That's a good thing, and the previous speakers just mentioned that in terms of trees. Well, those plants in the process of absorbing carbon dioxide produce sugars and oils, which we can convert into biofuels. And on the graph on the left, the farm is doing that. They're harvesting these plants, which are then converted to biofuels at a biofuel plant, essentially, and into fuels that are put into our car. And then we release that carbon dioxide back into the atmosphere. So what's the difference? We're still burning fuel. We were doing that with fossil fuels. We're doing it with biofuels. Well, the difference is the carbon dioxide that is being given off by the biofuels was in the atmosphere a couple of years ago, whereas with fossil fuels, it was in the atmosphere hundreds of millions of years ago. So in the ideal world, when we're using biofuels, there is no net gain in the atmospheric carbon dioxide, in theory. Now, the truth is, when you farm these plants, you are producing carbon dioxide because the farm machinery produces carbon dioxide. It's probably running on fossil fuels, for instance. So there's an impact to everything, including growing biofuels, which leads me to the statement that not all biofuels are created equal. I should say not all. I'm going to give you an example of a few biofuels, and you'll see what I mean. Ethanol is the result of the fermentation of sugar. It was also used when we were first building engines, but now we're looking at using ethanol. And we do use ethanol. We mix it with gasoline. There's corn-based ethanol, and there are problems with corn-based ethanol. 2 years ago, it was touted as being the solution to all of our problems. Now it's not. There are problems as a result of all these corn-based ethanol plants we're building, including the price of corn is going through the ceiling, causing the price of food to rise correspondingly. That's certainly an issue. Other issues are, in the farming of corn, we are introducing nitrogen and other materials into the water cycle, which is causing other problems down the road. And plus, nitrogen is also a greenhouse gas, or the nitrogen compounds that are released as a result of corn growth. So corn is not the final solution. It is just one possible way of approaching it, and perhaps not the best one for other reasons you'll see too. In Brazil, they've begun using sugarcane to produce fossil fuels. Sugarcane begins to ferment almost upon being harvested. You cut it down, it starts to ferment and starts to form ethanol quite quickly. Sugarcane is much easier to grow than corn. It's not as farming intensive, so that's a plus. Brazil has actually removed their dependence upon foreign oil entirely. They don't import oil anymore because of the fact that they grow their sugarcane, which seems like a great thing. The downside of it is, in the process of farming sugarcane, one of the steps involves burning the fields, which in and of itself introduces significant amounts of carbon dioxide, and also there's questionable labor practices involved with the farming of sugarcane. What would be perhaps the most ideal option of these would be to use switchgrass, which grows wild. We don't have to fertilize it. We don't have to weed it. We just have to harvest it. Switchgrass is lower in sugar. It's higher in cellulose, the roughage, the kind of stuff that cows may eat. That's more difficult to convert to ethanol at this time. It requires a technological leap in order to do it effectively, but with the introduction of microbes that may be able to allow the fermentation process to occur on cellulose, such a possibility is being researched heavily. On the other side of the biofuel spectrum is biodiesel, and that's really more what I want to talk about because that's more where my interest lies. If you take vegetable oil and you chemically process that vegetable oil to get rid of the glycerin, to remove the glycerin, and you can make soap out of glycerin, you can do plenty of things with glycerin, that's what the lower right bottle represents, you produce something called biodiesel. Biodiesel resembles, in a lot of ways, diesel number 2 that you can also buy at a gas station. But there are some important differences. One of the ones being that it is a biofuel and is not a fossil fuel. It also smells better when you burn it. It is a slightly lower energy content than diesel fuel. And we have 2 diesel vehicles, one of which is a Passat, a 97 Passat, which I've run both on regular diesel and biodiesel. And indeed, on regular diesel, we get about 39 miles to the gallon. On biodiesel, we get about 38. So it's slightly lower energy content than diesel fuel, but it's made up for in many other ways. It can be made from almost any type of oil or fat. It's biodegradable. I've read that biodiesel is less harmful to the environment than salt. Breaks down. That's not the case for diesel number 2. You don't want to get that on the ground. It burns cleaner than diesel fuel in the sense that it has lower particulates, it has lower nitrous oxide components in the exhaust, low and almost no sulfur content, and most importantly for the context of this conversation, lower carbon dioxide as well. Now, one of the perhaps most significant potential future sources of biodiesel is algae, believe it or not. Algae is the wave of the future, perhaps, in terms of farming biodiesel. Algae, there are some species of algae that are 50% oil. They are the highest oil content of any species on Earth in terms of actually getting oil from them. We're talking 10 to 100 times greater oil content than soybeans, which is typically used these days to produce biodiesel in the United States. Algae also can act to purify water that may be high in nitrate content, which causes problems, for instance, in the Gulf Coast. When all the farm waters run off into the Gulf Coast, they're causing a lot of algal growth in the ocean, which isn't where we want it. But if we put the algae along the streams, we can perhaps clean the streams, produce the algae, produce biodiesel, all at the same time. An important way to compare different types of fuel is to compare how much greenhouse gas, for every gallon of fuel that you burn, how much greenhouse gas is produced. So you can see on this graph here, diesel produces the most, but not by a wide margin over gasoline. We're talking about 24 pounds of greenhouse gas emissions, mostly carbon dioxide, produced when you burn 1 gallon of diesel fuel. Gasoline is slightly lower, coming in around 20 or slightly above. Corn-based ethanol isn't all that much lower, considering all the work that we're doing to produce it, and that's why. These emissions are not just the emissions associated with the fuel burning itself, but the emissions are also associated with the production of the fuel. We have to take the production into account as well. It's not just the burning, it's what did it take to get the fuel into your car. Of particular interest, the cellulosic ethanol has a very low greenhouse gas emission in pounds per gallon. We're talking about 2 pounds per gallon if we can perfect that technology. The other one, biodiesel, WVO. WVO stands for waste vegetable oil. So if you find waste vegetable oil, and restaurants produce it, including our food service here from cooking foods, you can take that waste vegetable oil, convert it into biodiesel, and you don't get counted against for the fact that somebody had to grow those soybeans or whatever they made the oil out of. The oil was already in existence when you converted it to biodiesel. It was already used for another purpose. It's kind of like recycling. So you get credits, if you like, carbon credits for using WVO. Another thing to look out is if I put 1 unit of energy into growing a certain type of fuel, how much energy am I going to get out? You want this number to be big. If I put 1 unit of work in, I want to get 100 units of work out. That's the ideal way to go. Corn ethanol that you see here, if you put 1 unit of energy in, you get 1.2 units of energy out. It's almost a zero-sum game in that sense. Yet we've been actively promoting that the past couple of years, if not longer. Sugarcane ethanol, like they do in Brazil, you get 8 units of energy out for every 1 unit you put in. So that's much better, which perhaps explains why Brazil no longer is dependent upon foreign oil. Different types of biodiesel, depending upon the seed that it is derived from, will give you different amounts of energy out compared to energy in. Soy, I believe, is about 3.5. Rapeseed is about 4.3. Algae gives you an energy out compared to energy in of 10. It's the highest of these listed here. Of particular interest, I want to point out hydrogen. Hydrogen is also touted as a fuel of the future. There's a lot of subsidies going into building hydrogen cars, which are a technology which has not been used in the public sector. It potentially could be very dangerous. Hydrogen gas is explosive, and it's a gas. You need to pressurize it to contain it. On this graph, you do not get even a 1 for hydrogen. In order to get hydrogen gas, you can say, well, hydrogen is the most common element in the universe. That's something you might learn in your basic chemistry class. That is true, but it is not normally in the gaseous state. It's normally on the Earth in a liquid state, in part of water. In order to get hydrogen out of water, you need to use electrolysis. You need to put energy in to get that hydrogen out. So hydrogen is not a fuel that you can just take and use. You have to produce it. So it does not come out highly on this. And very often, it takes fossil fuels to get that hydrogen. Now let's consider the diesel engine briefly. Why would I want to consider a diesel engine? Aren't they loud, sooty, and smelly? Well, we're thinking of the diesel engines of the past, of which there are many now for reasons we'll discuss in a moment. Current diesel engines, the technology has advanced significantly such that they are not sooty. They are not that much louder than regular cars, and sometimes they smell pretty good depending on the kind of fuel you're using. Why diesel? Because of the way the diesel engine operates. It was designed in between 1893 and 1897 by a guy named Otto Diesel, who wanted to make the engine more efficient. And he knew that to make the engine more efficient, he had to compress the mixture of fuel and gas as much as possible. So the diesel engine was designed to compress that mixture between 13 and 20 times what it is in the regular atmosphere. The gasoline engine might do it between 5 and 8 times. That gives a much greater efficiency to the diesel engine. New diesel cars these days get 50 plus miles to the gallon. And these are not hybrid diesels. These are regular diesel engines. Our 97 Passat gets close to 40. Newer versions of the Passat get well over 50. Diesel engines also survive longer, which is why you do see some of the smoggy, sooty diesels these days. The diesel engine has to be built heavier in order to attain the types of compressions that are needed to get these efficiencies. So they last longer. And that right there is going to be a savings in carbon because you need to build fewer cars if there's more diesels on the road. Every new car you build has a tremendous carbon impact, something we're not considering when we're just looking at the fuel. Newer diesels also reduce the stuff you don't want to smell and breathe significantly, and they can use biodiesel. In the United States today, our diet of fuel consists of about 140 billion gallons of gasoline each year and about 70 billion gallons of diesel each year. Just keep those numbers in mind for a minute. I'm going to just propose something. not that I'm going to advocate for this, this is where I would go right now. The scenario is, could we completely convert to biodiesel? It means all the gas cars would eventually go away, or maybe they'd go into ethanol. There's got to be a combination of tactics used here, but let's just take a look at this scenario. If all of the cars we owned were cars that could run on diesel fuel, and we could therefore run them on biodiesel, and grow our own oil through algae, as I discussed earlier, or some other high-yield crop, and then convert that oil to biodiesel, what would that look like? What might that do for us? And what would it take? Well, what it would take is 10 million acres to produce these algae farms. That may sound like a lot, and it is a lot. It requires a significant infrastructural change to our economy. However, if you compare that now to the 450 million acres that are used for crop farming today, that number doesn't look quite so big. And that crop farming includes farming for corn for ethanol. The cost would be about $310 billion to create these farms, and about $50 billion a year to maintain these farms. But that's money that we'd keep within our own economy. Currently, we're spending 100 to 150 billion on foreign oil each year, and that's money that goes away. So if we can look into the future with perhaps considering a possibility such as this, we may be better off. I want to just give a short personal story. I converted my car not to run on biodiesel, and there's some confusion on this. I converted my Mercedes, it's a 1984 300 SD. Those of you who know me know I have this car. It's converted to run on vegetable oil. So I have a separate tank in the back of the car that holds vegetable oil. And one of the sources of my vegetable oil in the past has actually been our campus food service. And it works. You need to run the car on, in my case, I use biodiesel to heat up the car, get it running hot. And I flip a switch, and it runs on vegetable oil. And you can see in the lower right picture there, I have my own vegetable oil gauge and a vegetable oil switch to control when I turn on and off the vegetable oil. It's kind of fun, actually. Some interesting numbers. Well, they're interesting to me. Maybe they'll be interesting to you, because everybody asks me about them. Well, how many gallons have you used so far? I've used over 600 gallons of vegetable oil over the past 2 years. I just tallied it up. I keep track of everything I do on this car. That's nearly 12,000 miles run on vegetable oil. And why I like that is it's because that's 12,000 miles where I did not create a net carbon impact, because, again, the carbon dioxide from the vegetable oil was in the atmosphere. So it's even a lower carbon impact than if I use biodiesel, because biodiesel takes some processing to produce it. The average mileage of my car wasn't so hot. I would have liked it to be a little bit better. It's a little over 18 miles per gallon. And I still want it to be better, even though it's just vegetable oil. Vegetable oil is still a fuel, and I still want to have better mileage. So there's some things I'm working on. And I need to have a method to filter the vegetable oil, which I do. It took some doing, but I got a way to filter it in an efficient way so that I can produce 600 gallons readily. And yes, I do my own auto work whenever I can. This was me in the middle of a brake adventure. It took a long time to get these done. With an old car, my car is older than most of the students I teach. It's a 1984. Things break down on it, but it's a diesel, and the engine can last a really long time. I've learned how much a tank of full fuel really weighs. I have a pretty good idea what's happening now. I have a very visceral way to equate liquid volume with distance. Dan's going to pull out my prop. It's filtered vegetable oil, which, yes, you could buy it, 60 miles. So that will get me 60 miles. So I have a pretty good feeling for how much fuel will get me how far. Thank you. So I have a greater appreciation for how much energy and carbon output is required to drive and to travel from place to place. It's a trade-off between my time and my money. Yeah, it doesn't cost me anything, but it's cost me a lot of time. But I'm much more engaged with the driving process. I think twice about where and when I want to drive. And by golly, I really want to use that diesel car, my vegetable oil car, no matter how old it is. That's the one I want to use, because I don't want to increase my carbon footprint. Direction for the future. Cummins, who developed many types of diesel engines, once said that an engine and the fuel it consumes are inseparable partners, which is an important consideration as we consider the next generation of biofuels and car engines. I thought of that, and I thought, wow, I can actually extend that to both ourselves and our Earth, that we are inseparable partners. So, thank you.